The research I will share with you today is part of a larger project that was funded by the United States National Science Foundation that I just completed. It involves interviews with 75 industry professionals, most of whom were engineers or applied scientists, as well as conversations with hundreds more through my work at the Colorado School of Mines and participation in conferences and events and visits to active mines as well as oil and gas facilities. The purpose of this project was to understand how engineers who practice in the mining and oil and gas industries understand the social responsibility dimensions of their work and how they integrate social responsibility into their professional activities. There was also an education component of this research. So we took what we were learning through the ethnographic research and integrated into undergraduate engineering curriculum at the 4 universities that you see there. We ended up working with about 1,200 students. And this is, I can only share a little of this project with you now, but the full project is published in the book that you see there, which is called Extracting Accountability, Engineers and Corporate Social Responsibility. And that book is available freely, open access on the MIT Press website. I wanted to start the talk, though, by signaling that my interest in the mining industry goes back farther than this research project. I come from a coal mining town in northeastern Wyoming, here in the States, in the West. My dad was a coal mine mechanic, and my job in summer, like most of the kids I grew up with, was to go work in the mines. So when I was in college, I drove the haul truck there. That's me. And so I became very interested in the mining industry and understanding the lives of people kind of who work in it. And as long as I've had kind of one foot in and one foot out of the mining industry as someone from a mining town, but also someone who is an academic, my view is that the key challenge to improving public perception of the mining industry is balancing these two different functions of public engagement. One of those functions is education, so teaching people about mining and why it's important and how it's important. But the other function is really listening and trying to understand what local concerns and questions about mining are. And in my view, the industry has spent a lot of time learning how to do the education piece and still has some room to grow in terms of listening. And these two activities can exist in tension with each other. So in terms of the education portion, in the United States, at least, there's a very well-organized mining trade group that puts out a lot of information about how much we need mining for our everyday lives. So here you'll see a poster that's published by the Minerals Education Coalition about how much you need mining to do something as simple as ride a bike. When I go to the SME conferences, there are a lot of companies there, and many of them make this same argument that without mining, we wouldn't have modern life. So here you see that being stated explicitly on the left, and then in the right, in the Komatsu advertisement, they're trying to show how having a cell phone relies on the minerals that you see there. And in Colorado, we also have something called the National Mining Museum. And what they've done on one of the floors is they've recreated a home full of appliances. So they have a kitchen, they have a living room, they have a bathroom. And for each piece of material that they have in this home, such as a coffee maker or a toothbrush or toothpaste or food, they have a little sign that says how much you needed mining in order to have any of these things in your house. And in my research, I call this an ethic of material provisioning. And what I mean by that is that there is a sense that the mining and energy industries, including the people who work for them, are good because they provide the material basis for modern life. And this is a really deeply felt sense of self. So many of the engineers and workers that I came to know really felt that their work was important, because without them, we wouldn't have cell phones, we wouldn't have electricity, we wouldn't have anything to build our homes. And there's a lot of truth to this idea. At the same time, my concern is that by continuing to invest in this one message, we haven't really changed public opinion. And I say this because I have traced back 100 years to the 1920s, and the mining companies have been saying basically the same thing. So back in the 1920s, the Anaconda Copper Company here in the United States took on the slogan, "From mine to consumer." And then in the 1940s, they ran a series of advertisements that positioned copper as necessary for building all of these houses as the suburbs were growing in the United States, arguing, quote, "There's copper in your radio, copper and copper alloys in your refrigerator, plumbing and heating equipment." And we can put this side by side with a more contemporary advertisement by Polymet Mining, which is a group that hopes to open a copper nickel mine in northern Minnesota. And what they have on their website is, quote, "Found in everything from wind turbines to diabetes test strips, cancer treatments, and car exhaust catalysts, the metals from our project are essential to our everyday lives. Imagine life without electricity, cars without pollution controls, and medical care without many of today's medical devices." So even though these are 100 years apart, it's a very similar argument, right? That consumers need mining. And my worry is that even though we've had 100 years of this message, people still don't have better opinions about mining. Public perception hasn't changed enough. And I think this is because when we focus so much on educating the public without listening to the public, it can be very alienating. It feels like lecturing, and it reinforces stereotypes of the mining industry as being big and powerful and indifferent to local concerns, kind of if we're just giving people a lot of information. And so the place I'd like to start instead is summarized by an engineer I met who said, quote, "You can't talk your way out of a problem that you engineered yourself into." And I really like this idea, because typically when we think about engineering and in the context of the mining industry, we tend to think about that as that being the place where decisions are made. And then you get a team of anthropologists and others to go do public engagement and to go get the social license to operate after all of these decisions have been made. And people who practice in industry will tell you that this is not efficient. So it is much more efficient instead if you can have public engagement from the beginning and feed in the information about social context and local concerns and local needs into the planning of the mine itself, instead of thinking about it later. And so it's this two-way relationship that I'm referring to in the title of my talk when I refer to contextualized project planning, implementation, and assessment. So it's actually planning and building and running a mine already aware of the social context. So with the rest of my talk, I'm going to give you some examples of what this has looked like in practice. Some of these are historical, and then some of these are contemporary. So the first company I wanted to start with is AMAX. So AMAX was a large multinational diversified mining company that was highly active up until 1978. And the reason why I focus on them is they were really out in front of the rest of the industry in thinking about community acceptance. So this is the front cover of one of their magazines, in which they are putting out social acceptance as one of their key responsibilities and goals as a mining company. And where this really started for them was here in Colorado, where I live, in a place called the Henderson Mine, which is up in the beautiful Rocky Mountains, as you can see in that photo. So AMAX originally planned and opened and operated that mine, and then it was eventually taken over by Freeport-McMoRan. So it's a molybdenum mine, and it's one of the most productive molybdenum mines in the world. But what most people don't know is that it was originally planned and permitted in the 1960s and early 1970s. And in the United States and elsewhere, this was a period in which there was a very strong environmental movement. And that environmental movement did not want any new mines opened inside of the United States. And so what the AMAX engineers decided to do was, instead of ignore the environmentalists and just go forward with the project based on their legal right to open it, they invited ecologists to sit down with their design engineers, with the geologists, with their business people, to design a mine that could be as socially and environmentally responsible as possible. So this is what the final mine plan looked like. And what you'll notice is that there is this very long underground tunnel that connects the actual deposit with the mill and tailings facility, which is all the way on the other side of the Continental Divide. And the reason why they did this, instead of having the mill where you might expect, which is right by the mine site, is because the ecologists determined that the more environmentally safe and sustainable place to be was on the other side of the mountain. So they built an 8-mile long tunnel. They also did kind of other interesting things, but that is one of the biggest decisions that they made. And the mine was able to open on time, and it's been a big part of the local community here. And so what was important for AMAX was, when they went to expand beyond that mine in Colorado, they were able to point back to everything they had done well in Colorado as an example of why people should trust them as they were looking to open mines elsewhere. So one of the places they were looking to expand was northern Minnesota, where there's currently a lot of controversy. And one of the engineers I met said he got off the plane, and immediately there were 26 environmental groups that were opposed to the project and ready to shut it down. And they eventually gave them approval to sink their first test shaft because of early, proactive, and open planning. And so what AMAX had done was they invited the environmental groups, they invited kind of government officials to go out to the potential mine site and see everything they were doing, especially when it came to water monitoring. And so these groups that originally opposed the development project later commended AMAX for, quote, good faith, complete openness, and cooperation for the water quality monitoring already done. The next place AMAX was looking was Crested Butte, Colorado, which is another picturesque and beautiful mountain place. And Crested Butte was very interesting because it was starting to develop an outdoor recreation industry. So there was a major ski resort that had just been opened, and there's also a world-class molybdenum deposit there. And so when AMAX announced their intention to test and open a mine there was a huge conflict at a national scale between the company and the Sierra Club and other organizations. And AMAX did the same thing. So what you see there in the front, these are the AMAX officials. And then over here you have local government officials, and they hosted very big public meetings. And normally in the process of environmental impact assessment, a company will plan a mine and then present those mine plans to the public, and people can kind of stand up and either say yes or no, or explain why they're opposed or in favor of a project. And what AMAX did was very different. So instead of presenting a completely finalized project, they presented a draft project and they asked for feedback so that they could adjust certain decisions. And one of the engineers who later became a lawyer who I interviewed really summarized their approach to public engagement well. And he said, quote, "If we want agencies and the public to hear about and understand the benefits of our projects, we must be willing to seriously listen to them and to involve them in the planning and programs which are designed to address their objectives and concerns." And so this is one of my favorite examples. This is their main design engineer. And what he's doing in this photo is he's explaining how their choice of mining method, whether it was block caving or a room and pillar method, would change how many workers they would have to bring at any one time and how long the mine would be open. And so he was very good in all of the transcripts that I read of explaining how every technical decision that they made had a social impact. And so they wanted to optimize the social responsibility of the project through their technical decision making. So now to turn to a more contemporary example, I'd like to talk about the Buckhorn mine, which is in Washington here in the United States. This is a gold mine. And what's interesting about this project is that the first time a mining company came in and proposed a mine, they received all of the permits. They were planning a very large open pit mine, but there was a huge backlash because as you can see, this is a really beautiful area. And a lot of people had moved to this part of Washington to really enjoy the environment. And they were able to launch a very successful campaign. And the mine had all of its permits revoked by the state of Washington. And so the project died. And a few years later, a separate company kind of came back. And instead of proposing a very large open pit mine, what they did was they proposed an underground mine. And what was smart about that is they said that the underground mine would have 95% fewer environmental impacts. And this was a very powerful statement. And so it was much harder for the environmental group to oppose the mine because it had a much smaller environmental footprint. So they were able to open it thanks to that design decision. And the one thing I would say is that this is more of a mixed bag in terms of whether the mine was successful. So the mine produced a lot of gold and jobs and taxes for the county, but at the same time, they were not really responsible, especially in how they managed water. And so they're currently under investigation. So the last case of really participatory planning that I'd like to talk about isn't related to mining, but to oil and gas. But I want to share it because it's a very compelling case that I think really illustrates some of these principles. And the mining and oil and gas industries share common problems in terms of public perception. So this is a map of Denver right down here. So everything you see in yellow is a city. So basically what happens is there's an interstate highway that goes straight north of Denver to other towns. And it's just a lot of people have moved here. And so there are a lot of housing developments and lots of people. What you'll see on the next kind of image is an overlay of where the oil and gas industry had oil and gas wells. And so a lot of these were the new kinds of wells that combine horizontal drilling with hydraulic fracturing. And there was a huge controversy about fracking here in the United States. And so what you can see is that these two activities, kind of oil and gas development, was trying to happen next door to where a lot of people were living. And the problem was even worse because the blue and the green show where they were planning new fracking development. So this was a very controversial era for the oil and gas industry in Colorado. And one of the main things that local communities were concerned about was all of the truck traffic. So at each of these well pads, they were very large. So one well pad could have 24 wells on it. And in order to service these wells, it required about 20 months of truck traffic that included 55 to 108 round trips per day. So if you can imagine, you're a person who has a home and you're seeing trucks go back and forth 100 times a day, you can imagine that it'd be very concerning and disorienting. And so what this meant was in Colorado and around the US, this kind of fracking debate became very contentious. And what Colorado did was interesting, and they set up memorandums of understanding, an MOU, that they would sign between an oil and gas operator and a local government. And those MOUs were really interesting because basically what the companies agreed to was to abide by higher standards for social and environmental performance that were set by the communities in exchange for more secure and timely permitting. So for example, in one of the communities that my research group studied, people were very concerned about the lining that was being used in a lot of these ponds. And so in the MOU that they signed with the oil and gas operator, they set out very strict requirements for the lining for that pond. And other towns signed agreements about noise levels or operation times. And what we found was that in places where there was an MOU between a company and a community, there was more trust in local government, and there was greater acceptability of industry. And what was interesting for us was that this greater acceptability stayed even when the performance was objectively worse. So some of the places we studied, there were problematic wells that had flares and emissions. And if there was an MOU, people still had better opinions about the oil and gas industry than people living in places without an MOU. And so some of the companies that I got to know, one of the ways in which they were very successful is by setting up a listening function inside of their company. And they assigned that listening function, not just to an anthropologist such as myself, but to a multidisciplinary team that would include engineers and geologists and other geoscientists. And they would find ways of actually adapting their infrastructure to address social needs. So for example, one of the main concerns that I explained was truck traffic and trucks going through neighborhoods, by homes and by schools and by hospitals. And so one of the companies wondered if they could be more responsible by, instead of having trucks go to each individual well pad, if they could create one place, they called it a stimulation center, that would be connected by pipeline to all of the different pads. And they could inject all of the materials from that one place. And so the trucks would only be going to one place instead of to each individual well. And this is what it looked like after it was built. And so what all of these examples have in common is that they were able to achieve a social license to operate because of the way they did social engagement. So they did not just share information about how important mining was or about how safe oil and gas development was. Instead, they went out and they listened to local communities and they integrated them into the actual planning process itself. And the people working for these companies, the employees, really became representatives of the project and became a friendly face out in the community. So a CEO of a transnational mining company who I interviewed summarized this importance of listening really well. He said, building strong relationships begins with being transparent about what benefits the community can be expected and by, of course, listening closely to what our communities are telling us. What are their values? What are their priorities? What's their vision for the future? What are their expectations for participation in the development? I think it's time that we start to think about issues like this around CSR as an investment, just like confirmatory drilling or early test work in labs. Early spending on sustainability issues is just good long-term business. Especially as engineers, we have to talk less, listen more, and listen to our communities. So I think the last case I want to show is moving from the planning stage to the actual operations stage. And what makes the Eagle Mine really interesting, and this is a mine in Michigan, is that it was opened relatively recently. There was a lot of environmental opposition, but the company had committed to two-way communication. And one of the most interesting things they did were the community scorecards. And so what they did was, through focus groups, they sat down with the community and they set out what are their priorities. And their priorities were environmental performance, local hiring, safety, communication, and leaving more wood on the wood pile, which referred to their environmental kind of commitments to forestation. And so each time they hosted a community meeting, they would give a survey, and everyone in the community could rate the company about how well they were doing against each of these priorities. And what was interesting is that at the very beginning of the project, there were a lot of people who would show up to these meetings. And then as the mine continued operating, kind of attendance went down because people's concerns had been addressed. The other thing that was really important for this mine was they funded an independent third party to do air and water quality monitoring, so that the public would trust it more than if the company was doing it itself. So in all of these, kind of, there's a focus on doing the public engagement in the planning phase, and that it's two-way communication so that companies can listen to, learn from, and adapt to social context, and then feed that back into the mine design. And this is really different than the traditional approach, which is to only engage the public in the permitting phase after all the decisions have been made. And oftentimes this decide, announce, defend approach is one-way communication, in which the company is just sending information out into the world and not really listening. So lastly, quickly, I just want to point to the workforce development opportunity that we have. I think there's a big need to train students to factor social concerns into their engineering decision-making, and in speaking with the professionals that I got to know working in industry. So one of the things that we noticed was engineers were increasingly being asked to represent companies in public at community meetings, at hearings, in the backyard when someone had a question about mining. And so what we did was we helped take everything we were learning through our ethnographic research and train our students to do these things as engineers, so that they could start thinking about corporate social responsibility very early on as something that they were accountable to. So we worked with over 1,200 students at these 4 universities, primarily with these majors. And our assessment work really focused on the students who did a survey at the beginning of the class and at the end of the class, and who gave informed consent for us to use their information in our research. So we have about 840 students who we can analyze from the beginning of the class to the end to see how much our teaching influenced their thinking. And I've published more of this elsewhere, but just briefly, our findings were the following. The first was that as a result of these kinds of learning activities, students were more able to identify social performance as a key dimension of engineering responsibility. It's much easier for them to think about the environment and the economy as being relevant to engineers, but our work was able to help them think about the social dimensions of their work. We also found that students broaden their views of legitimate stakeholders to include activists opposed to their industries. And to me, this signaled that Students understood they had an obligation to people who disagree with them. Even if they can't change their mind, that's still someone that they need to engage. We also found that students came to identify compromise solutions that would address local concerns while allowing industrial activity to proceed. And lastly, we found that specialized electives preach to the choir. So I teach a corporate social responsibility class at Mines, and I had always suspected, but now have evidence to show that students who are showing up for this elective already score very high on social responsibility dimensions. And so for me, this is a real invitation to collaborate and to do joint teaching between social scientists and engineering faculty inside of engineering courses where all of the students are, because those are the students that we really need to reach. And so for me, if I think about the future of mining, the one I'd like to think about is moving from social acceptance to social acceptability. And the difference I'm signaling there is that social acceptance really places the burden and the problem on what people think about mining and how do we change how people think about mining. Whereas social acceptability really emphasizes how do we design a mine from the beginning that is socially acceptable, so that the mining industry has a role to play and it recognizes that people's perceptions are linked to decisions that they make. And I think my research and others show that it's through contextualized project planning, implementation, and assessment that we can move kind of toward that future in which we're not just aiming for people to accept mining and to tolerate, but to really welcome mining as a part of their own local economic development. And so with that, I will end and I will leave my contact information up there. And I thank you very much.
Thank you, Professor Smith. I would like to know if someone has some questions.
Yeah, I'm happy to answer questions if there's one.
Professor Smith, can I ask something? It's Ramona Kosalova here from Greece. Thank you, first of all, very much for your presentation. My question is first of all, I never have considered just a simple MOU could do such great things and fill the gap or make the bridge in order to those two different ideologies. I don't know how to say it. Can be somewhere can be come to the middle. Anyhow, can we consider all of these strategies and actions as a part of ESG approach?
Yes. Yes. And it's been exciting to see the importance of ESG grow and the acceptance of ESG grow in the mining industry. And I think what's important about an MOU or other companies, especially who work with Indigenous populations, they will sign something called an impact benefit agreement. And I think what's important about these legal agreements is that it creates a formal mechanism for defining the relationship between the company and the community, instead of it just being voluntary on the part of the mining company. So when you have a legal agreement, it is enforceable, right? And so I think the community feels more empowered, and that there is another mechanism of accountability, and instead of just a company saying they're going to do the right thing.
Yeah, great. But in the case where the community and the needs of community, or at least the requirements, are not heard enough from the company, what then?
I don't know. In Colorado, we haven't had that happen, but it would be good to look up what recourse or resources communities have if companies don't hold to their legal agreements. I think at that point, they have more of a case to hold them accountable than if it was just a promise that was made.
So maybe even like going to some legal think there is some issues in
Yeah.
this level. Okay. Yeah. Okay.
Yeah.
Thank you so much. Thank you.
That's a good question. And that's what happened in the case in Washington, in the Buckhorn mine in the Okanagan Highlands. So the company did not respect the agreements they had made in terms of water management. And so now the state of Washington is investigating them. So I think you're right.
Yeah, okay, thank you. At least here in Greece, it's not like they don't I don't know argue about something. I mean, they don't agree on something. Actually, we have the approach like just public awareness. That's all.
Yeah.
Yeah. So this is very good just to know it for future implementation of any project.
Yeah, I think it is so powerful when people feel like they've had a voice and that the company has listened to them and adapted. Hi, Juanma.
Hello. Okay. Okay, Jessica, thank you very much for your amazing presentation as always. Okay. We know you have classes now, so I have just a quick question if you have 2 minutes, because I would like you to tell you about the possibility or the reality of implementing your proposal, because this is what we want. Okay. So we know that there are several good examples also in Australia. We have some interesting up to down actions, okay? But tell me something about what under your perspective, what do you mean? We have to, which keys we have to touch, okay, first to try to make this a reality?
I think the difficult thing is that each place has different concerns a lot of times. And so companies want to create one corporate social responsibility strategy or one ESG plan, and then they will implement it in all of the different places where they operate. And it's very clear that that doesn't work because you have to adapt to the local context in each place. And so I think identifying what specific local concerns are, and then really doing some thinking about how can we address them and how we're planning the project from the beginning. So are there little things that we can switch, such as where we are locating a tailings facility, or which mining method we are using, or which processing method we are using? Kind of what levers do we have that we could adapt?
Okay, we have to make some work, I guess.
Yeah, always.
Okay, so really thank you for your presentation. Thank you for your time, your collaboration. We hope we still continue in different projects also. Okay.
Of course, and good luck with the course. Thank you.
Thank you very much. Thank you very much, Jessica. Okay, we have now we have Oscar Jaime Restrepo, which is he just sent me a message. He needs 4 minutes to arrange the Zoom connection. So let's wait just 4 minutes. He's entering yet, okay? Let's take a 4 minutes rest. Okay, Professor Oscar Jaime, welcome. Can you hear me?
Hola, Juanma, how are you?
Oh, nice to see you, Oscar.
Sorry,
Okay.
give me 2 minutes in order I prepare my presentation, okay?
Perfect, don't worry. Lina, can Oscar share his screen? Can you
Yes,
confirm?
sure. Yeah.
Okay, perfect.
Hello, Professor Oscar Jaime. Welcome.
Hi, Lina, how are you?
Good, good.
Dear Professor Juan Maria, how are you? Good morning. Good afternoon. to you.
Good afternoon here. Good
Morning in
there.
Colombia.
Very nice to see you again.
Thank
You
you very
can
much.
share your presentation.
Yes, I'm going to put my presentation now. Sorry for my delay. I was in a class and I finished my class, and now is Professor Jessica also here, or she finished the presentation?
She has to leave because she also has classes. So
Okay.
this is our life.
Okay, let me present. I'm sharing my presentation now. Can you hear? Can you see that?
Yes. All
It's
good.
still black here.
No, I
It's,
can.
yeah, me also, Lina, I can see it clear here.
Yeah, I can see as well.
Okay, perfect. Okay, Professor Juan Maria, I'm ready. Let me know when I'm going to start.
Okay, you can start. Lina made a short introduction, but we can take the opportunity just to say that Professor Oscar Jaime Restrepo is full professor at the National University of Colombia. He's a minor engineer and doctor in minor engineering also. And he works a lot in the, of course, technical issues, but especially in socio-technical approaches to mining projects. So, Oscar, the floor is yours. You can start.
Sorry, can you hear me now? I lost my connection.
Yeah, but you are online now. Go ahead,
Can,
don't worry.
can you hear me now?
Yeah.
Yes,
Thank
all
you.
good.
Okay, perfect. Okay, good morning. Thank you. Good afternoon, you in Europe. Good morning here in this part of the life of the continent. We are in Colombia, South America, and this moment are 9:49. And thank you very much for your presentation. Thank you very much for the invitation. Thank you very much for share this moment and to have the opportunity to discuss with you. I had the great opportunity to share with the different professors, Professor Juan Maria, Lina Villa, and Professor Jessica, and the rest of the presenters that we are sharing with you today. My presentation is about sustainable processes in mineral raw materials production. It's important to discuss about the fundamentals of sustainability in mining. My presentation today is based on the different experience we had here in Colombia with artisanal mining. But at the same time, I think it could be possible to discuss different opportunities, different experience, or different conditions that we found in different kinds of mining. Okay. My name is, as Professor Juan Maria says, I am Oscar Jaime Restrepo Aena. I'm professor at the School of Mines at Universidad Nacional de Colombia in the Materials and Minerals Department. This is my place. And the idea is to share with you some experiences about these topics, these different topics in sustainability. Okay. Okay. Sometimes when you are talking with people about sustainability or mining, when you are talking about mining, people think that mining is something like this. Some people believe that mining is terrible things. Some people think that mining is destroy the rivers, destroy the nature, or destroy the mineral resource. This is the concept that some people have, but it's not clear, it's not real, because at the same time, we have different experiences in good examples of how to extract the raw materials in order to obtain minerals, in order to grow as a society, in order to grow in different places, in different options to improve the level of life of people. This is the thing. This is not the options. This is the option we are looking for. This is not the real things. This is the things we could have as a real experiences. Of course, this kind of things exist. Yes, of course. But this is the thing. These are the things that we want. We need to work in experience that help us as a society not destroy the environment, don't destroy the nature, don't destroy the mineral resource, grow with the mineral resource. And I think it's important to do that. It's important to say that mineral is important, that mineral is mining. Mining is a very important activity we have to do in order to grow as a society, to improve the level of life of people, improve the level of life of society. Because when we extract the mineral resources, we are working in job generation, and it's very important to create job generation. It's important to create a new regional development, create new circumstances for people, create new options for society or for communities. But at the same time, it's necessary to work in create environmental sustainability. It's important to receive royalties in order to invest in the society. It's important for our societies receive foreign investment in order to create new options, new opportunities to improve, to grow. We are looking for new benefits of the extraction of the raw materials in order to assess the condition of the society. Sometimes it's not easy because we have to think about what it means. What means to have a sustainable development or to create a sustainable growth after obtaining the raw materials? What it means. That's why we have to work in that. During the 40 years ago, in the 1987, it's not very far in the time. It was 35 years ago. Now you could think that it's a long time ago, but it's not a long time. Only 35 years. We established one of the first concepts about sustainability. It was the Brundtland Report in 1987. In that report, the definition of sustainable development is the development that meets the needs of the present without compromising the ability of the future generation to meet their own needs. It was revolutionary to think that. It was very important. It was it's like a milestone, a very important moment in life, because in that moment we established that it's necessary to think about the future. Maybe the first approach about to care the nature, to care the environment was in the 60s, but the 60s is very small time. It's a short time. It's not a long period of time. 60 years in the context of the humanity is a small period of time. Okay, since the 60s to the 80s, 25 years, we established a new concept in order to think about the future, to create, develop in our society, in the present society, thinking about the future. But at the same time, this concept have a new evolution. This concept changed, of course, because the concepts have to evolution. We need some evolution of the concept also. And the new concept or the develop is that sustainability is a paradigm for thinking about the future in which the environmental, social, and economic considerations are balanced, and in the pursuit of the development and a better quality of life. What it means, we need to think about the future, or the future generation. We need to think about the environment. But at the same time, we need to think about environmental, social, and economic issues, because you need to create opportunities for the future. And that's why the concept evolution, we have an evolution. It was in 2011, 10 years ago. And we continue evoluting in the concept, because it's necessary to think about how we are going to approach the society in order to grow. We need to grow, of course, but in one sense, we need to grow. In that sense, that is why it's very important to balance, to think about sustainability is a balance. It's a balance in which you have to think about the society. You have to think about the population growth. You need to think about economical resources, but at the same time, you need to think about the future of the new generations. And when you are thinking about that, you are in a balance. You need to think about the mineral resource, the raw materials, how to extract them, and what are the consequences of extract the raw materials, and what are the consequences to transform the raw materials in final products. You need to think about the technologies. You need to think about the results of the use of technologies. You need to think about the investment on the create new infrastructure to do that. To think about modern techniques, about extractions. You need to think about the results in terms of the what kind of raw materials are you using now in the present, and what are the results, what are the not only the products, also the tailings, because one of the most important things is to balance. You as a professional, we as engineers, we need to think about the flow sheet. We need to think about it, not only the raw materials, also the reactions in the reactors. The reactors could be the mine, for instance, or the mineral processing plant, or a chemical reactor when you are going to obtain a product. But at the same time, you need to think about the product, and in the same balance, you need to think about not only in the product, also in the tailings, also in the gases, also in the wastes. You need to think in the same dimension. That's why I say it's important to balance, because the investment is very important, because the people are very important, because you need to think in a complex way. It's important to think about that. When we are thinking about the development, the first ideas was to think about the money, was to think about only one dimension concept. Development of the societies was a concept in only one dimension. And in the beginning, the dimension was only the economical topics, financial topics. But it was after during the last 50 years, people think about only one dimension of economical issues. In the 60s, as I told you a few minutes ago, in the 60s, we started to think in another dimension. That's why it was important to think in two-dimensional concept of the sustainable development. One was the financial topics, and the other was the environmental topics. And it was very difficult to try to change that. It was very difficult because it was very complex when some people started to think about the environmental. People in the 60s, people start to say, hey, they care with the environment, they care with the atmosphere, they care with the soils, they care with the water. Because before the 60s, it was very difficult to think about that because we think only one dimension. After the 60s, we started to think about the concept of the environment. It's necessary to think about the environment for the next generations. And we change. As always, sometimes when you change, the conditions are difficult to change. It's difficult to imagine that it's not possible to think in only one dimension. You need to think in two dimensions. But the concepts continue improving, growing, changing. And that's why after the 80s or during the 90s, the first years of this century, we start to think in another dimension. That's why we started to think in a three-dimensional concept of the sustainable development. It was important to think that it's not possible to think only in the economical issues or to think only with the environmental topics. It was necessary to think about the social issues. That is why it's necessary to think in a socio-technical approach to the problems in engineering, but not only in engineering, in all dimensions of the society, or all dimensions of your work as a society. Because sustainable development is not only one direction approach. You need to think in a complex system, a system that is worried about the financial topic. Of course, the economical topics is important, necessary, is important. You think about the environmental and how you are going to take care of the nature, the physical, biological issues. But at the same time, you need to think about society. You need to think about communities, of the social issues. And it's very complex topic because in three-dimensional approach, you need to consider all the single topics, economical, environmental, and social. But at the same time, you need to think in B-dimension, economic and environmental, economic and social, and environmental and social approach. It's necessary to think immediately, it's necessary to think in all the dimensions simultaneously. And it's very complex. But nowadays, in this moment, the three-dimensional concept is not enough to continue working. It's not enough to have the approach. Now we have another point of view, a four-dimensional approach to the sustainability development. We have another variable. Besides the economical issues, environmental issues, and social issues, we need to consider the new direction, a new dimension. That new dimension is the time. Because we conclude that the topics that could be important now are not the same that are going to be important in the future. And it's necessary to consider day by day, year by year. It's necessary to consider the new conditions, obtain the development in the 4-dimensional analysis: economical, environmental, social, and time analysis. Because if you are going to think about the situation, it's necessary to you think about that. In the past, or 10 years ago, the conditions are very different than are the conditions today. And in the same consideration, 20 years ago, 30 years ago, 50 years ago, 100 years ago, the conditions are very different. And that's why it's important to think about how is the environment now? How is the society now? How is the economical situation now? It's completely different. That's why it's necessary to think about social and cultural change over the time, to think about how economical change are over the time, how environmental change are over the time. And in the same considerations, the 3-dimension we are considering how they are changing. And this is a very important condition. This is completely different. And we have to think about that. In mining and in raw materials extraction, it's the same. Think about the conditions today in raw materials. We are now using smartphones. Today it's very important to use smartphones, but 30 years ago nobody used that. But what things we need to obtain smartphones? We need a very strange or a very rare elements that are in the nature. The elements are now here, yes. 30 years ago, yes. It's the same thing, but 30 years ago we don't need them. Now we need that kind of rare elements. We know about the existence of the rare elements 30 years ago, yes, of course. But 30 years ago, the needs we had about that elements are very minimum. Now we have a lot of use of that kind of elements. Of course, the technology changed. The technological issues change. And now we need to extract that kind of elements that in 30 years ago we don't need to extract. And the technical conditions to extract are different because we have different kinds of machinery, we have different conditions of technology in general. And the approach is different because society are very different. How were the society, our society 30 years ago? Very completely different than they are now. That's why we have to consider that special things. That's why the principles of sustainable development we have to think about society, environmental, and economy, and at the same time, the time analysis. But not separately, no independently. We have to think then join. It's not necessary, it's completely different. It's like analysis, a complex analysis, because the extraction of raw materials is a special of the complex world, a complex world that need to assume the complexity. It's necessary to approach in a dimension, in a 4-dimension approach, simultaneously work in all that directions, because the conditions are different in every moment. We have to work in dimension of the social and economical, because the world needs to be equitative. We have to work in environmental and economic world in order to do it viable. And we have to work in a social and environmental world in order to facilitate the life conditions. All that things working simultaneously is the sustainable development. It's different than to work separately, all of them. That's why it's necessary to think in a system structure. We have to work the environmental system is different than local and simple analysis. The analysis, the complex analysis, the complexity is very important to think about in a systematic structure, because all of the situation impacts in different way the world. We have to think about the natural system, and we think to think about the system organization, the organizational system. In the natural system, we have to work in the biotic system with fauna, with flora. In the natural system, we had to work in the physical system with air, water, soil, underground analysis. But at the same time, in this complexity, we have to think about the organizational system, sociocultural system, economical system, a political system. And all, if you work in one of these points, immediately you affect other part of the system because it's a complex machine. It's not independently. If you work in the political system, maybe you can change the water conditions. If you change the flora, maybe you change the air. If you change the air, you change the sociocultural analysis of the situation. This is the thing. It's a holistic analysis. It's a holistic point of view. It's not independently. You need to work very close. And if you are thinking about what are the principles of the sustainable development and how is evolving the concept, the environment, the economic analysis, the analysis of the economy, that was the first analysis we have in the past, now is complemented with environmental and the environment is complement with the society. In what kind of things? In things like to have the right to a healthy life, or to have the right to have development, or to have the possibility to poverty eradication, or to work in the direction of the environmental protection, or promote appropriate policies to live in society, or maybe to have gender equality. What is that? The evolution of the concept. That's why the United Nations were in this special topic in 2016. The evolution of the concept is now to work into generate new conditions to the develop. And the extraction of raw materials had to be focused to get these goals, sustainable development goals, 17 goals to transform the world. This is the new concept of the development. If you are going to work in the development, it's because you are working that the society don't have poverty. Unfortunately, our countries, we live in an undeveloped world because exists inequality, because it seeks hunger, and the extraction of raw materials, the mining activities have to be focused in no poverty, zero hunger, and good, healthy, and well-being conditions for the societies. Equality education is not, it's a holistic point of view. If you're going to extract the raw materials, it's because you are going to develop. If you are going to develop, it's because you are going to fight the poverty. It's because you're going to reduce inequalities. It's because you are going to have responsible consumption and production. All of these goals are linked, and the mining activities and the extraction of raw materials are linked, are focused directly in create conditions in order to get these kind of goals. We have to work in that direction. It's not a theoretical approach, it's a real approach. In the different scales, big scale, big mining companies, medium scale, small scale, also artisanal scale. It's possible to get the goals, the sustainable development goals for artisanal miners, yes. For artisanal extraction of raw materials, yes. We have to think about that because exist possibilities for all. And this is the extraction activities. Extraction of raw materials are considered in different points of view, in different scales, in all the scales that we are working, that could be working, are focused in these 17 goals. We have to work in that. We are extracting raw materials in order to produce smartphones. Why? Because the idea is to have decent work and economical growth for the societies. Yes, it's an holistic point of view. We have to work in that direction. And the question is mining sector possible? Is the mining sector consider the conditions, or the mining sector or the extraction of raw material consider the politics or the new approach of the sustainable development? Some authors says that no. Different authors said that mining is unsustainably. It's impossible to be sustainable. Some authors says that. And maybe they could have right. Why? Because they don't consider the mining activities as an holistic system. If you consider the extraction of raw materials, the mining activities as a holistic point of view, as a very complex work, mining can contribute significantly to the social, environmental, and economic aspects of the necessary for the sustainable development. But only in the case you consider the extraction of raw materials are an holistic activities. All the activities you do affect all the aspects of the society, all the aspects of the system, economical, environmental, social, in the time. If you consider mining activities in mining sector with this point of view, could be possible. And the question is, which are the requirements for do that things, for consider the situation in that direction? You need to think that it's necessary to work in resource conservation, demand protection, operational safety, profitability, qualified human resources, work a lot in education of the people, and to have public acceptance. You have to work simultaneously in all the topics in order to create the conditions. There are the requirements in order to create the conditions to go in that direction, to consider the mining activities are an holistic system, a very complex system that affects all the parts. If you think in that direction, maybe could be possible. In that sense, is it possible to think that mining is sustainable? Yes. If you don't consider mining activities like this, because in this sense, you are not considered an holistic topic. You are not considered a holistic options. You need to create, you need to work and avoid conditions that impede, that restrict, that opposite to the development. Now you have to work in conditions that work in order to support people, support society, create new conditions, create new options, and create new options for people. I am presenting here a special example in a local region here in Colombia. The name is Bajo Cauca. donde exist millions of gold reserves, donde exist at the same time low productive yields and a very low percentage of recovery. You have to work in that. We need to work in that in order to create conditions in these regions in order to avoid environmental deteriorations, fight against social problems, and increase competitiveness. At the same time, you need to work with people, with government, support the government, coordinate activities in different levels, involve the communities, involve the companies, involve the government, involve new technologies, cleaner technologies, in order to obtain better capacities of the people or the communities for the new options of the conditions. You need to create conditions for cleaner production. Cleaner production means you are involving the people. You are continuous, comprehensive, and preventive environmental strategy. You have to work in the environmental issues. You have to work in create or management the resources. You have to work in the reduction of bad environmental impacts. You have to work in creating new technologies and approach technologies for people. If you need clear production, you need to work with the different aspects of the system. It's a complex system, yes, but you need to work with the complex of the system. Sometimes people don't want to change or necessary to change. You need a very high cost of the technologies, yes, but you have to fight with that. And you have to involve the authority, you have to involve the people, you have to involve in order to develop the mining regions. You have to control, you need commitment, knowledge, planning, and execution in order to involve communities. You need to involve people, you need to involve a very important thing in this part, in create new conditions for the sustainable development is education. You need to educate communities. You need to work with the communities. Technical and training, yes, it's important. Business model, yes, it's important, but at the same time, work together that. This is that socio-technical means. It's not necessarily only one topic of the society or one topic of the development, not only the technical issues. You need socio-technical issues in order to create a cultural change in the people. You need to involve or include individual strategies and regional strategies in order to be conscious that it's necessary to work together in different topics, in create social development, economic development, and incorporate the environmental issues to manage the situation, to manage the conditions. And these are the 10 principles of the sustainable mining in different levels that is necessary work ethical in the business in order to involve governance, in order to create conditions for the corporate governance systems. It is necessary to integrate the issues of the sustainable development that we are considering this point in this discussion. It is necessary to involve fundamental and human rights. It is necessary to implement risk management, improving the health and safety sector, create continuous improvement in the environmental aspects of the exploitation of the raw materials, work in biodiversity, work in the responsible use of the products, be conscious that it's necessary to work in all dimensions. Is important, not only the product, also the tailings, also the wastes, also the gases. You need to work in all dimensions, and all the byproducts are very important. And of course, in the same time, the same level, you have to work with social, economic, and institutional development. It's necessary to create the condition of information, communication, and mechanism of the conditions. In that sense, it's possible to consider the sustainable development if you integrate the social, economic, and environmental issues in different topics, but also in the perspective of time. What it means that sustainable development is a function of rational use of the natural resource, of course, economic growth of the communities, yes, and of course, social equity is the conditions of the universal equation of the sustainable development. The sustainable development is a consequence of the extractive of the raw materials. Without the extractive industry, it's impossible development for the societies. We have to work in that. We have to work in training, education, and of course, in create conditions for our society, for our people, for our communities, and for, of course, for the professionals. We need technological skills for the new professionals, for the communities, for the people, but at the same time, social, political, and ethical skills. We have to work in that. We have to work necessary in that because we have education in technical and social, political, and ethical topics. If we have a socio-technical approach to the problems, maybe we could think about the challenge we have in the future. This is my presentation. I hope we are in the time of the presentation. If you have any questions, let me know. This is my email, and I have a YouTube channel. If you are interested in my approach, you can use this link in order to discuss about some topics about sustainability, about extraction of raw materials, and different topics that could be important for you as professionals. Thank you very much. Let me know if you have any question. Professor Juan Maria, thank you very much. I'm here in order to answer the question that the students could have.
Thank you, Oscar. Thank you very much for your presentation. We were sort of checking the chat. There's no question, just some congratulations to the speaker.
Hello.
You,
Hello, I have one question. Sorry.
Yeah, Fernando, go ahead.
Yeah. Oh, yeah, it's really a pleasure to be in this dissertation. I'm Fernando Zegarra from Peru, South America. Okay, your neighbor, Mr. Restrepo.
Hola, Fernando. Thank you for
Hola.
your participation.
Okay, I have one question. It is very current to have problems with indigenous communities in Latin America. I would like to know, how do you manage this issue in Colombia, please?
It's a very complex approach because we had to learn a lot about the communities. Not only indigenous communities. In Colombia, we have some indigenous communities, but mining activities are forbidden there. But with local communities are very complex approach. One of them is because we don't understand communities, and we had to learn about the communities. And our approach is try to live the condition of the communities. And that's why it's important to have a different approach. One approach is the 3P approach. The 3P approach means presence. You have to be there. Presence. You have to be in the communities. Presence, persistence. You have to be there all the time. This is one of the most important problems we have. You have to be there and stay there. And the other P is passion, because you have to understand the communities. You have to learn about the communities. You have to learn how they are talking. You have to learn how to listen. It's very difficult for us as an academic, as a government, as a mining companies, try to understand the needs of the communities. Because we sometimes, in the most of the cases, we think that the problems that the community are the problems we say that. Sometimes it's different. We have to listen about the problem they have. And that could be the first step before to have a mining project. Sometimes, in the most of the case, we have the project and then we go to the community after the project. And this is the problem. We go to the community with the project and the community says, why? It's your project, not my project. This is one of the most important things. We don't know how the communities talk, and we have to learn. This is my approach, Fernando.
Yes, thank you, because here we have that problem that we get a lot of resources, okay, metal these resources, but the problem is to face the communities, okay, to understand them, as you say. Yeah. Thank you. It's
Okay,
clear.
thank you, Fernando.
Okay.
I think a socio-technical approach is very important. Traditionally, we privilege the technical approach. The project for us, the most important thing in a project is the technical solution to the project. And we create the conditions for the technical solutions for the technical problems. And we says, okay, these communities are important, yes, but communities import is because it's necessary to work in the territories, to go to the territory, involve the communities in the project before to have the final project. And it's very difficult. Yes, it's very difficult. And it's not common. It's not common. And for me, from my point of view, it's necessary to be living in the territory before to have the project, the final project, to understand the territory before to have the final projects. Because the socio-technical dimension is very complex. I'm clear that it's difficult to understand or try to do it in the practical topics. What is the idea? It's difficult. You have to work that difficulty.
Okay, thank you.
Okay, any other question over there in the chat? Not questions. Okay, so Oscar, thank you very much for participating.
Okay, Professor Juan Maria, thank you very much. Thank you very much. I'm ready to support or to answer any questions you have. I will be here in the presentation, listen to the other presentation. Thank you very much. Okay. Thank you, Lina. Thank you, Lina, for your support.
We appreciate your
Professor.
cooperation, Oscar. Okay, so I guess we can make a step towards. We have the next presenter over there. Yeah, Mateo.
Yes, Mateo is here.
Ah, okay.
Yes.
Hi, everybody.
Hi, Mateo. Okay, Mateo is former student from the National University of Colombia, current student of PhD student in the Colorado School of Mines. Okay, so Mateo accepted to share with us the research in which he was involved. I guess it's very, very aligned with the topics that we are dealing here in this presentation. So, Mateo, floor is yours, and thank you again for your cooperation.
Thank you, Professor Juan Maria, and thank you, Lina, for organizing this this course and for giving me the opportunity to share a little bit about what I've been working on here at the program at Colorado School of Mines for the past year and a half. So today I'm going to be delivering my presentation. It's titled Improving Artisanal and Small-Scale Gold Mining Practices in Colombia Towards an Empowering Approach. And I'm going to be connecting it with these themes of social acceptance and the acquiring of critical raw minerals for the EU. So to start out, so as many of you may know, the EU just released the Critical Raw Materials Act, which is aimed at ensuring a secure and sustainable supply of critical raw materials for the EU. And among several other things, this act emphasizes setting targets for the production, refining, and recycling of key materials, including rare earth elements, to reduce the dependence on imports and strengthen the EU's supply. And one of the internal actions of this plan included protecting the environment by improving circularity and sustainability of critical raw materials, which you can see there in bold, which the EU says can help promote the economic development in third countries, and also the sustainability governance, human rights, conflict resolution, and regional stability. So while this act has this focus on strengthening the extraction of raw materials in the EU, it also recognizes the importance of improving the conditions of the existing supply chains. And one of the minerals that will continue to play a role in the energy transition that is acquired from countries outside the EU is gold. So in a 2018 report, the World Gold Council emphasized that gold has considerable potential in a range of applications that can help reduce greenhouse gas emissions. And while it's not listed on the EU's critical minerals list, gold is already used in several technologies relating to renewable energy, electronics, and telecommunications. And the production of renewable energy technologies like solar panels, wind turbines, and batteries require significant amounts of gold. So for example, solar panels use gold in their conductive electrodes, while wind turbines use gold in their electrical contacts. Gold is also used in electronics and telecommunications for its high conductivity and resistance to corrosion, which are really important properties for ensuring the longevity and the ongoing reliability of these devices that we use every day and will continue to use as we transition towards renewable energy. So this really shows how gold is essential for this transition to a low carbon economy and digitalization, which is what we're looking towards in the upcoming decades. And there are already several initiatives in the EU and internationally that are seeking to introduce responsibly sourced gold into the supply chain. So for example, the European Partnership for Responsible Minerals is an accompanying measure to the EU Conflict Minerals Regulation that was passed in May 2017, which focuses on introducing responsibly sourced tin, tantalum, tungsten, and gold into the supply chain. And the EPRM has partnered with several other organizations, such as Impact and Solidaridad, not to mention the other international organizations like the Initiative for Responsible Mining Assurance, which is working to set a standard for independent third-party auditing and verification and certification. Or another example is the Alliance for Responsible Mining, which works directly with artisanal and small-scale gold mining and operators to assist them in meeting what they have their fair mine certification, which verifies their responsible practices and allows them to acquire more income from their mining activities and introduce their responsibly mined gold into supply chains. So it is well known that the gold supply chain is very complex. There's a diverse range of actors that are formal and informal, as Prof. Oscar mentioned, including artisanal and small-scale miners. This is in addition to traders, refiners, manufacturers, investors, and consumers that are all involved in this web of stakeholders. And these complexities have been, and it's been shown that these complexities require an integrative approach to address. And our NSF research project titled Responsible Mining Resilient Communities has been carrying out research about sustainable gold mining practices in Colombia and Peru since 2018. This is an interdisciplinary, international, and multi-institutional research project that spans across several universities that seeks to understand how miners, mining communities, and engineers understand and respond to the risks related to artisanal and small-scale gold mining, and also seeks to propose socio-technical solutions that make this sector more sustainable for miners, their communities, and the environments that they work in. And this socio-technical approach that Prof. Oscar was mentioning before, that we emphasize on this project, is rooted in the principles of the Humanitarian Engineering and Science program at the Colorado School of Mines, which is where I've been carrying out my thesis research over the past year and a half. And at the Humanitarian Engineering and Science program, we focus on integrating the social sciences and engineering in a meaningful way to collaborate directly with the communities that we seek to serve by identifying problems and working together on sustainable solutions that emphasize social responsibility and sustainability. And these tools are really important in the ASGM sector, which, as I mentioned before, has these really diverse range of actors that interact with each other and depend on each other in diverse ways. This is especially true in the artisanal and small scale gold mining sector, which produces up to 20% of the world's gold and provides 90% of all employment in gold mining. And these activities often have ancestral and cultural ties, which contribute to their persistence and development, but also make introducing sustainable interventions difficult. And while there's not an agreed upon definition of artisanal and small scale gold mining, it broadly refers to the use of rudimentary tools to prospect, mine, and process gold. And this sector produces between 25 to $30 billion every year, has up to 20 million miners working in this sector in over 70 different countries. But the main issue that many international development organizations, universities, and government agencies are seeking to address is the over 2,000 metric tons of mercury that are released into the environment every year by these activities. And the main source of mercury pollution in the ASGM sector are the processing plants where artisanal and small scale gold miners bring their ore to be processed. So pictured here is what's called, is one of these processing plants in Colombia, which is locally known as an entable. And these have a collection of small ball mills or cocos, where miners will bring the ore that they mine from the underground and they'll deposit them into these mills, which will rotate. And the small balls will grind up the ore until it becomes a sand. And then miners will also deposit mercury into these ball mills, since mercury and gold are chemically attracted to each other. And at the end of this process, they'll finish with a small mercury gold amalgam, which is a ball of mercury and gold. Then they'll heat this amalgam to enough so the mercury is smelted and vaporizes into the air, and they'll be left over with a small ball of unrefined gold. The tailings or the waste products from this process are left behind at the processing plants as payment to the processing plant owners, which then use cyanide and other methods to recover up to 70% of the gold, since the methods that they use are more efficient than the use of mercury, which only actually recovers about 30% of the gold from the ore. But this actually, and the reason that miners depend on this is because this is the mainstream version, or this is the mainstream method of gold processing in many communities in Colombia. This also generates a waste stream of mercury cyanide complexes, not to mention the significant amounts of mercury that are vaporized into the air through the smelting of the mercury gold amalgam. This also creates an imbalance of power, since the processing plant owners use more efficient methods and end up recovering most of the gold that was originally in the ore, which prevents the miners from ever having the opportunity to save up to invest in their own processing equipment, and they have to continue depending on these processing plants. And there's been several interventions that have been introduced to try to reduce these levels of mercury and improve the practices in this sector. One particular intervention that has gained a lot of attention in Colombia is the communal processing facility, which would be a way to empower miners to be the owners and main beneficiaries of their gold processing by bringing their ore to one location where they could be in charge of more efficient technology that didn't result in the release of mercury into the environment, causing all of these human and environmental health issues. And this collective model of gold processing has empowered some mining communities in other countries, such as Mongolia and Peru, but the ongoing operation of this model has not been successful in the specific national context of Colombia. And there has yet to be a study that seeks to understand some of the reasons behind this failure, which is what led to the motivation for my study, which sought to understand miners' perspectives about collective systems of gold processing. So to try to understand these perspectives, I conducted ethnographic fieldwork in the Department of Antioquia in Colombia this past May through June of 2022. And this Antioquia, the Department of Colombia, produces 65% of the country's gold, 87% of which is produced from the informal sector. So to understand these perspectives, I conducted 35 semi-structured interviews, had a focus group, conducted participatory mapping and observation of ASGM sites. And to get as holistic of a picture as I could about the perspectives of this sector, I tried to interact with a variety of stakeholder groups. So this ranged from me prioritizing artisanal and small scale gold miners' perspectives to government officials, lawyers, and mine administrators that work in these contexts. So now I'm going to pivot to discuss what I saw in 2 case studies in Antioquia. The first community that I visited was called La Maria. And this is a community in Antioquia that received a large influx of miners in the mid-1950s from other areas in northeastern Antioquia. And when the miners arrived to this community, they brought the mainstream form of gold processing at the time, which was gold amalgamation, which I explained before. And they were using this method up until they up until the presence of a large-scale gold mining company arrived in the area. And this large-scale gold mining project acquired a concession in the region. And part of this concession included the area where the artisanal and small-scale gold miners had been operating in La Maria for over 50 years. And after originally failing to incentivize the miners to leave the area by providing them with a one-time payment, the large-scale gold mining project had to negotiate with the miners and ended up coming to an agreement that they would provide them the resources to form a mining association and hire a management team to ensure that they were meeting the standards that were outlined by Colombian mining law, to make sure that they were working in the formal economy and meeting all of the regulations. The large-scale mining project also promised to build this community its own processing plant to replace the Entable, the processing plant that was using mercury in this community that was being used in the past. While they were waiting for their plant to be built, though, they had to use a third-party processing plant in the area to process their gold. And while I was in this community, the people that I spoke with, specifically the miners and mine administrators, readily recognized the benefits of working in the formal economy instead of working in the informal economy, saying things like they don't have to run from the police anymore, they're able to benefit from having social security and medical benefits, and that they don't have to use mercury anymore, citing the the well-known environmental and human health effects of using mercury. But this recognition of working formally was complicated by their lack of involvement in this current arrangement, where they bring their ore to a third party that has a processing plant to process their gold. And when I spoke with the mine administrators in this community, they stressed that they're no longer involved in the processing of their gold, and it's hard for them to trust that they're being paid fairly for the gold that they're bringing to this third party processing plant. And this system that they exist in now differs greatly from the system that they had in the past, where it was highly polluting and used mercury, but they were able to see the gold see the ore that they took from the underground transform into gold, and they were involved in every step of the process. So that they weren't involved in that process anymore, there were differing levels of trust. So some people stated that they were fine with the plant, and some people stated that they felt like they weren't being paid fairly. So after spending time in La Maria, I realized that all of the stakeholders that I interacted with supported the construction of their own processing plant. So like I mentioned, there were some differing perspectives about the trust for the plant, but everybody that I spoke to wanted to have their own plant, showing that they preferred an arrangement without the third-party plant, and they preferred an arrangement where they would be able to be the owners and be able to oversee and be in charge of their own gold processing. So those were the observations that I saw in La Maria. I'm now going to pivot to the second case study that I focused on, which was the community of Frontino, which is also in Antioquia. And the reason that I focused on this community was because it's home to a communal gold processing plant that was built in 1995 that ended up closing very soon after its inauguration. So most of the mining activities in Frontino take place on what miners call the Cerro Plateado, or which means Silver Hill in Spanish, which is located over a dozen kilometers from the center of Frontino and borders with a national park. The miners that work on the cerro use these small-scale processing mills, which are called arrastres, which use water power to make large rocks grind the ore. And you can see in the photo on the slide that these arrastres are scattered around the cerro in Frontino. And miners have been using this technology for over 150 years to process their gold. So here you can see a video of what this looks like. So in the arrastres, there's two large rocks that are rotating because of that are rotating from water power, that are grinding up the ore and turning it into a sand. So after miners grind up their ore in the arrastre, they pass it through what's known as a sluice box, which you can see on the bottom two pictures, which uses gravity to separate the heavier gold particles from the lighter rock particles. And the higher levels of free gold in Frontino have allowed miners to extract enough gold to continue using this chemical-free system. When I say free gold, I'm referring to the gold that can be liberated just by grinding and gravity concentration and doesn't necessarily require the use of, isn't required by using chemicals. So while this wasn't the most efficient technology, the properties of the ore allowed miners to extract enough gold that they were able to continue depending on mining as a livelihood. And miners have been using their empirical knowledge about how this arrastre system works for over 150 years. They've been passing down this knowledge and sharing it with each other. And this allowed miners to control every aspect of their arrastre, from how long they were going to grind the rocks up to when they wanted to pass it through the sluice box to who was going to be in charge of different parts of the processing. But the use of the arrastre also interfered with their adoption of more efficient, but maybe more environmentally harmful technologies, and affected the levels of technological development in Frontino. So here on the slide, you can see more mechanized processing equipment, which is known as the Molino Californiano. And the miners that I spoke with mentioned to me that a small minority of miners use this more mechanized equipment on the Cerro, but the majority continue to rely on the arrastres. So while I was there, I realized that the preference or the prioritization of the environment ended up leading to the persistence of the arrastre system over more mechanized equipment like the Molino Californiano. And this also allowed for a system of self-regulation, which prevented the use of mercury in Frontino. So when I spoke to miners there, they told me that there's a system, or they don't allow other miners to use mercury. So instead of reporting them to the environmental authority, they will actually go up and confront them and tell them that in Frontino, we don't use mercury to process our gold. So after spending time in Frontino and realizing and understanding how the arrastre system works, and then seeing how this compares to the processing plant that was built there in 1995, it became clear why this plant wasn't successful in the long run. So this processing plant was built over a dozen kilometers away from the Cerro Plateado, and it ultimately didn't fit the socio-technical dimensions of the community. There were few options available for miners to transport the ore from the Cerro to the processing plant that was located in the center of the town. The arrastres that miners were using also harnessed water power and didn't have any electricity costs, and they would have had to accept an additional cost in the form of paying a fee to use this plant. And beyond just economic and logistical infeasibility, miners had very little incentive to transition from a system, the arrastre system, which allowed them to employ their knowledge about gold processing and gave them the opportunity to be in charge of the process, to a system where neither of those would be prioritized. And the result was them not understanding the demand about the demand for the processing services, and there being a distrust for this system of gold processing, which was unfamiliar to them. And this distrust can be seen really clearly in a quote that one miner told me when he talked about the plant, saying that usually one does not let another manage their processing plant. That's like giving someone a roll of money without counting it. So this disconnect between the design and location of the communal processing plant and the lived reality and needs of the miners shows why we need to start with the perspectives of the miners and community members in these types of projects. So after spending a couple of days with this miner, Luis, he came up to me and expressed that he wanted to share an idea that he's had for a while that could improve miners' yield and reduce the levels of pollution that are being released into the water systems by the tailings of the arrastre system. So we had this idea of building a system of tubes or canals where miners could deposit their tailings, and gravity would bring these tailings down to a central location in the bottom of the mountain where they could be processed at a communal tailings facility. And this facility would extract the residual gold left from the tailings, and the income could be reinvested into the community or into the mining activities in Frontino. So the fact that this knowledge exists in the community and that this miner felt comfortable sharing this with me after having spent several days of building trust and rapport with him shows that these types of highly context-specific ideas that are needed for sustainable interventions already exist within communities, and that people feel comfortable sharing with them after you've built a relationship based on mutual trust. And if the implementing forces behind the communal plant that failed had gone to Frontino, had interacted with the miners to understand these dimensions of the processing activities, they would have been much better positioned to develop a project that built on the local assets and accommodated local needs. So what can we learn from these two case studies? So one of the conclusions that I had for my thesis was that the vision of communal processing plants in Colombia has been limited to one of just economic and technological efficiency, which has inhibited their success because there isn't an idea of how these plants could serve as forces of empowerment for ASGM communities. This really shows that projects need to consider the extent to which miners' agency is constrained or preserved by their projects, and ultimately shows that these projects need to consider the socio-technical dimensions of the community, and that miners must be integrated from the outset to build on the existing capacities, knowledge, and socio-political organizations in these communities. So looking forward, it's as we're considering these questions of the critical raw materials and the social license to operate, it'll be essential to continue providing visibility to the artisanal and small scale mining sector. It'll also be important to go beyond these one-dimensional interventions that have been implemented in the past, that have been either purely technical or purely social, and need to consider how these two dimensions depend and interact with each other, and consider efforts that strengthen miners' capacities. And these considerations have clear implications for the improvement of the raw materials supply chains in Europe. So circling back to the Critical Raw Materials Act, the European Commission mentions that, among other aspects, this act will help the importance of, shows the importance of building a more resilient supply chain and a strong and sustainable level playing field. And these considerations are especially important in the gold mining sector. As long as gold is a valued commodity among humans, artisanal and small-scale gold mining will persist. So as we're considering these questions of social acceptance, resiliency, and sustainability of mining activities, we must consider how we can support efforts that will place miners and their communities at the center of these projects by strengthening their capacities to improve their practices in a sustainable way. Thank you all so much for your attention, and I will now take any questions, and feel free to reach out to me after the presentation for any more follow-up.
Okay, Mateo, thank you very much. Really interesting your research. And let's see if there is any question in the chat. I guess no one in the chat. Perhaps someone in the audience want to address some question to Mateo?
Yes, hello. I have one question. Sorry, I'm very related with the mining industry here in Peru. My first question is, I saw a CIP, a carbon in pulp or a cyanidation plant that the artisans are managing, okay, in the jungle, in the Colombia jungle. So how do they do the cyanide destruction in order not to pollute the areas, the rivers and other lakes and other,
Yeah, so I can't speak directly to that plant, but I think I do have an understanding of how it happens at the artisanal scale. So my understanding is that most of these entablis, which I mentioned at the beginning, which use mercury amalgamation, there isn't very much cyanide management, which is why, and this ends up in the release of mercury cyanide complexes, which are actually more bioavailable than just mercury or cyanide by themselves. And this is why this has become such a big issue internationally. In terms of the formal plants that have, for example, the communal processing plant in Frontino that was going to be constructed, they work with engineers and they work with government agencies to follow the standards to make sure that they're following all the regulations that are in place to manage the cyanide. So those issues, so the issue of cyanide contamination isn't as prevalent since they're working with engineers that have familiarity with how to manage the pollution from the system.
Yeah, understand. Yes, this is a big problem here in this part of the world. Yeah. Yeah. So I have one question. The other question is, they are using mercury, so they sell the mercury, getting the gold inside it, or they have to dissolve the mercury and then they recover the gold nuggets. If so, they have problems with with the evaporation of mercury. And this is a real contamination. Yeah, I don't know. What do you think?
Yeah, I mean, I think that issue that you outlined is the main issue that people are seeking to address. So I mean, there's the environmental and the human health consequences of mercury are very well researched. And I think now the question isn't as big of like, what is the effect of mercury pollution or how is that affecting people in the environment, but more, what do we do about that? So a lot of interventions in the past have focused specifically on just mercury use and have introduced things like retorts, which could capture mercury vapor that's evaporated in the air, which can be helpful in some contexts, but that doesn't fully address these socio-technical dimensions, these ancestral ties, the presence of armed groups, the these really complex dimensions that go beyond just introducing a single technology that is supposed to, fix this issue of mercury pollution. So I think what I'm trying to show in this presentation is that when you begin with the perspectives of miners and the people that live in these contexts that have been working in these areas for such a long time and have this really context specific information, that's a really good place to start to understanding what types of interventions might be sustainable. So the communal plant that was built there ended up failing because these dimensions weren't taken into account. But the other project, the communal tailings facility that the miner had, seems like a much more feasible project. That was actually, that when I spoke to other mining engineers, they told me that this could be something that's feasible.
Okay, thank you.
Thank you.
Okay, any other question? I guess, Ramona, did you raise your hand before?
No, I was uploading.
Okay, sorry. Perfect. So if there's no question or additional, I guess, in the chat, no. So Mateo, thank you very much for your presentation again. Thank you for joining us at this in this course. Okay, and we wish the best things for you in the present and in the future in your research. Okay,
Thank
I
you,
hope
Professor
we
Goldman.
keep in contact.
Thank you
Okay.
so much. Enjoy the rest of the course, everybody.
Okay, thank you very much. Perfect. So I think we are a bit the time with a bit delay. I am the next presenter, so I guess I'm not going to introduce myself. Okay, and I'm going to share my presentation. And see if it works well. Okay, can you see it full screen or just?
No, it's not in full screen mode.
Okay, I think I have to, start full screen first and then share. Okay. Yeah.
Perfect.
Okay, thank you. Okay, let's start with the last presentation of this course. Okay, and as you have in the prompt, my name is Juan María Menéndez Aguado from the University of Oviedo, and the title of my presentation is "Who and How Does Mine If We Don't Mine?" Okay, probably if we gather together everything that we see in the presentations in the yesterday session and in the today session, we almost have the panorama, the whole panorama of what is happening now or what is the problem, and even we have the problem with mining, and also we have some ideas of how to address or how to find the solution of our of this current situation. Okay, I would like to start just with a quick presentation, raw numbers of my university. Much of the people in the audience, I guess, that they know, but just in case, my university, the University of Oviedo, was founded in the 17th century. Okay, at that time was the Pope who gave the permission to establish a university, and a bishop was the founder of our university. Okay, we are the only university in the Principality of Asturias, which is a region of Spain. We are a middle-sized university with 20,000 students, 2,000 lecturers and researchers, 1,000 administrative staff members, and as you can see, a number of degree programs, undergraduate degree programs, master degree programs, and PhD programs. Okay, we have almost 20 faculties and schools and almost 40 departments, and our annual budget is slightly higher than 200 million euros per year. Okay, so We are located north of Spain, as you can see. Main cities are Oviedo, which is the capital city in Asturias, Gijón, which is indeed the biggest city of Asturias. And we have a small city, which is Mieres, which is the place in which we work in the Polytechnic School of Mines, Polytechnical School of Mines. And the share of students among the cities, as you can see, Oviedo is the first one in number of students. Then we have Gijón, which is mainly devoted to also engineering programs, and Mieres, this is our Polytechnic School of Mieres, with a small number of students, also devoted to engineering programs, okay, undergraduate, master degree, and PhD program. Okay. This is a quick view of our geological map. As you can see, doesn't matter you have a big knowledge on geology. If you see this, you can imagine that many things happened in the past in our region, and this is why almost we are a small region in Spain, just only around 1 million people, but we are the mining reference region in Spain, along with Andalusia, which is southern Spain, and the first one in coal production in the past. Okay, currently we are the only coal mine which is running in Spain. Our school was founded in 1954 with mining studies, mining engineering studies, and this is why we are located here in the new campus. It was built in 2002, inaugurated, and you can see that this is a small village of rather 40,000 people, and we have 1,000 people here in this campus. So this is really a small village, a small university village in Asturias. Okay, perfect. Mateo just in the former presentation told something about the Europe situation, or the Europe concern about raw materials. Okay, I would like to share with you a quick view of how is the situation now regarding raw materials in Europe. Probably the spark of the concern is this number. 30 million plus jobs in Europe depend directly on the availability of raw materials. Okay, this is why in 2008 the European Commission started to focus and to study on this fact, started to study every production chain in Europe, and noticed that we perhaps in the past years focused too much in these production processes, try to leader some technological fields, but at the same time we forgot that we need raw materials, and in some of the value chains, really there arise threaten about the possibility of a lack of raw materials to this production. Okay, so this raw materials initiative focused in Europe. The raw materials are considered all raw materials except agricultural and fuels. Okay, so for instance, wood is a raw material and is studied as a raw material in Europe. Okay, but almost 90% of the raw materials considered in Europe are mineral raw materials. Okay, And the three pillars in this raw materials initiative was to get a fair and sustainable supply of raw materials from global markets. Second one was a supply also sustainable from internal markets. And the third one is to enhance the recovery of secondary raw materials in this context of circular economy that is now everywhere, okay? So this lead to a the critical raw material definition, which was a list reviewed periodically. We have the last one until 2 weeks in 2020, but 2 weeks ago, the Commission in this Raw Materials Act that Mateo mentioned before, in the communication, because it's not yet approved, they show the new list of raw materials, which is almost the same that 2020 list, okay? Only some influence on the conflict, Ukraine-Russia conflict. This conflict had serious influence on some specific raw materials, okay? And this is why this had to be reviewed. In 2010, the Commission also started with the European Innovation Partnership on Raw Materials as a stakeholder platform, and it opened to the society, or try to open to the society to define how, from the politics point of view, how policies could be developed to address this issue, okay? So at the end, we can go to the end point, which is the just a couple of weeks, the European Union Critical Raw Materials Act, which in fact is a point in which several positions are clearly stated regarding the production of raw materials, ensuring the supply of these materials to the production chains without forgetting sustainability concepts, without also forgetting the social acceptance of this activity, okay? So this opened a very nice future, I guess, for us, and I hope we soon are going to see the effects of this policy, of this new policy. Just a quick shot of the raw materials, the former raw materials list, the 2020, in which you can see that we define in Europe criticality, or the criticality analysis based on the economic importance in any production chains in Europe. And in the vertical axis, you have the supply risk, okay? So all of the points you see are raw materials which are studied periodically. Depending on the conditions, some of them are systematically within the critical area, as is the case of magnesium, metal, of niobium, okay, phosphorus, cobalt, platinum group metals, tungsten, okay, rare earths, which are in this area of high supply risk, perhaps not so economic importance now, but as Professor Oscar Jaime told us, perhaps in 5 years the situation can be very, very critical, because as the economic importance of these raw materials grows, they go to the right of, they have a displacement to the right of the graphic, okay, and probably in the next revision, these rare earths are going to be in this area, okay, of high criticality. Okay, And this figure, which was prepared for the Commission, European Commission, it is very interesting because we can see which in Europe are considered the strategic sectors, which are the sector of renewables, the electrical mobility, and the sector of defense and space. These three sectors rely greatly on several technologies which were identified and which are which have the priority of the Commission to fund, to boost research on them, to help to projects, the development of projects of those technologies. Okay, as you can see, you have batteries, fuel cells, wind energy production technologies, traction motors related to electrical mobility, photovoltaic panels, anything related with robotics, drones, 3D printing, and ICT. These technologies, as you can see in the left part of the graphic, also need different amounts of raw materials, some of them with low criticality, as are the one colored in green colored, okay, and others with high criticality, as is the case of rare earths, red colored in the graphic. And this Sankey diagram, which is very, very interesting, show us that you can notice that no technology is free from criticality of the raw materials, no one of them. Some of them are highly dependent on critical raw materials, as is the case of traction motors due to and wind technologies due to they rely on rare earths mainly. Okay. Also, perhaps we have other elements not so critical as the rare earth, but also critical as magnesium, niobium, germanium, borates, and scandium, which are in almost all of the other technologies. So making at least interesting to address this problem and try to see how we can solve it. Okay, so Europe knows now clearly that we have to define a playground in which we can produce really, as we understand, sustainable raw materials or raw materials under a sustainable framework. Okay, and people have to know that this is why we try to project a different image. Okay, so I would like to present you what we call this is the fruit of discussions with colleagues, as Professor Oscar Jaime and other colleagues worldwide. So we call the paradox or the socio-environmental paradox of raw materials production, which society demands consumer goods which needs mineral raw materials for their production. This means mining activities, but people do not want to accept environmental consequences of that production. This is a fact. We know this was mentioned by Professor Smith. Also, Professor Oscar Jaime told us something about this. And this is, as what is known the NIMBY, or the NIMBY, not in my backyard paradox, okay? This is really a hard situation that we have to face, but this even has a second 2.0 version, which I would like to share with you, which is that almost the same paradox. Developed countries, whatever this means, okay, endow themselves with the toughest legislation in the field of labor. We have probably the best legislation framework or legal framework, okay, regarding labor and regarding environment. However, the costs associated to these aspects, also as Professor Oscar Jaime presented before, makes almost impossible to start mining projects, mineral raw materials projects in or at least at the level in which we can compete in the market, because this means, at the end of the day, this means that we have labor costs higher than other parts of the world, environmental costs that we also face and assume usually, okay, in the mining projects. So this situation in which we make ourselves difficult to produce promotes mineral production, as I say there, somewhere, somehow. And this is probably one of the darkest phases of the paradox. Out of sight, out of mind, as they say in English, okay? And okay, I baptized this 2.0 paradox as NIMBY or something like that. That could be not in my backyard, but yes, in the backyard. I haven't, or we apparently don't mind where are producing things, where are mining minerals. We just consume products that are produced, of course, under, we guess, or we think, good conditions, perhaps sometimes, not so good other times, okay? So if we just focus on the end of the production chain, just in the products, we lose the traceability of the origin of this, of course, raw materials and even of the processes. And this is a problem for us, out of sight, out of mind, okay? And we have to try to solve this paradox. How can we solve the paradox? Okay, we have two weapons, okay? The first one is CS. CS is common sense. And the other, also mentioned before, the Sustainable Development Goals, okay? Common sense is just trying to realizing that there is no, as Oscar Jaime also said before, there's no possible development, technological development, without the knowledge on raw materials, and of course the sustainable production of raw materials, okay? The history and the review show us that the more we master the raw materials or the elements, what we can do with the different elements of the periodic table, the more we get technological development, and consequently we expect social development. This is not always true, but okay. And regarding the Sustainable Development Goals, the SDGs, you know, you have here this link, which is a very interesting document that the World Economic Forum published a couple of years ago, in which you can see that any of the 17 SDGs is linked in one way or another with the mineral raw materials production. Some of them are clearly linked. Probably we we would quickly think about the 8th or perhaps even the 6th, but all of them are clearly linked. You can download this document. It's for free, of course, and you can take a look and think about the different implications, different levels of the mineral raw materials production and any of the 17th SDGs. Okay, so I guess being the last in presenting my presentation always seems that it has a good point that almost everything was told yet, so I can rely on this. Okay, this is rather funny at the beginning because the question, the title of this presentation was who and how. Okay, let's stop on who does mine, or who do mine in plural, if we don't mind, which is just one of the questions we have to make to ourselves. Okay, sometimes people who this out of sight, out of mind premise give us this kind of expectation. Okay, we don't know, but probably these funny dwarfs are over there caving and producing gems and minerals for us. Okay, but the sad part of this aspect is that not dwarfs, but little human beings are sadly over there producing the mineral raw materials that we are taking advantage of, okay, in our products. This is a photograph of, okay, you have here the article that you can also access and see. This is a cobalt mine in Democratic Republic of Congo, which is the main cobalt producer in the world, and also the country with the main reserves of cobalt in the world. Okay, so if and this photograph is 2020, so probably 2023, sorry, is the same situation. There is no changes in Congo as far as we know, RDC. So at least we have to think some minutes about this, okay? Because when we have the possibility of producing, for instance, cobalt, let's say cobalt, okay, in our countries, and we, with any argument, don't worry, we oppose this exploitation or the starting of this activity, we are promoting this other activity. Okay, if we open the mine here, it doesn't necessarily means that this situation, this sad situation of kids, little children working in mines is going to stop. This would be very, very basic to think this thought, okay? But what we know for sure is if we could distinguish, if we could have the full traceability of the raw materials in the value chain, okay, all value chains reflected in the final product, as usually we have in some food legislation, we have some letters, you know, A, B, C, D, and depending on the mix of you know, fats and sugar or whatever, they give a score. Okay, we could do something similar or it would be nice for us if we could reach that point, because people probably will decide buying things more expensive but more responsible, more green, really green, okay? So if we continue with this out of sight, out of mind position, we cannot see which is the reality, and this really is a weakness of our society. Okay, not always children are working, but being sad to be a child or a kid working in a mine also is very sad to be people working or to see people working as it would perhaps 500 or 1,000 years ago, okay, in the different empires that we have in the earth, okay. You see some images which are all recent, this Central African Republic or Congo or whatever, and not only Africa is the place in which we can find this, okay. And we see people working where machines could easily work, okay. And the problem, we have several problems that we are not going to analyze here, but my expectation is that you just think deeply about this and try to see how are the opportunities or which opportunities open if we decide, as Mateo presented in his presentation, if we decide that when I mean we, I mean responsible miners, okay? If we decide to, as European people, try to see how the value chain of this raw materials is, and we dare to even go there and try to make exploitations according to our principles, which are decent labor conditions, decent and responsible environmental conditions, okay? Of course, best available technology that we have would be, of course, interesting. And another situations different, I guess some of this was similar to one that Oscar showed you before. This is the real situation that we can find in the world, okay? I always say that there are many ways or many phases of mining, and we have to see all of them, but we have to support just the responsible one, okay? Okay, just to almost finish regarding who does mine or who do mine, okay? We can focus just on rare earths. We mentioned, Oscar Jaime mentioned before, the importance of these raw materials in the technological development, okay? Nowadays, almost even more than 70% of the production is centered in China. And is almost the biggest producer and the biggest consumer, because any or most of the production chains related to technology are also China based, okay? And this is not a problem of being Europe against China or whatever. Sometimes these geopolitical issues, I'm not an expert on that, seems to present the situation. The problem, for me, this means that China is a leader. Okay, and we cannot beat them. We perhaps can, as consumers, put some conditions when we consume goods, okay, and this perhaps can start making some change, okay, but China is a very big country, and we can find in China many companies also producing in different ways, okay? I'm just going to show you how China is not only in China, mainland, but also in the rest of the world, is investing in, even in Europe, investing in, of course, in Australia, of course, in Africa, of course, in America, okay, even in Canada. They are starting mining projects, trying to supply these worldwide value chains, okay, who needing mineral raw materials, okay. So this means that, of course, if we don't mine, of course, China is going to mine, okay. So this is an answer to the question that we initially, but the thing is, or the point is, which are the conditions that we are going to accept to the mining activity? Because if, as consumers, we can, or we have a right to put some conditions in the products we consume, probably this is the force we have. We are a premium market for Chinese products. So perhaps this is one of the possibilities we have to change the situation, okay? But regarding how do they mine, I just show you couple of statistics about, let's see, for instance, coal, okay? It is very difficult to find statistics about China miners' deaths, okay? But I could find this, and I make a comparison with the US, okay? See that in this perhaps later 10 years, in the past 10 years, the situation is not so bad, but in the past 20, let's see where we come from, okay, in China, okay? But okay, just focus in this last part of the curve of the statistic. We have 1,000, perhaps, let's say 300, okay? 300, which are made public in China as fatalities in coal mining, okay? In the US, we have in the same period, as you can see here, numbers which are clearly lower, okay? And this is the summary I put you here. The production in China is threefold the US one. But the number of fatalities, in the best of the cases, is 30 times the US ones, okay? So this means that the labor conditions are not the same. And I didn't include here European coal production because we had almost full closure. We still produce coal in Poland, of course, in Germany, even in Spain, okay? But the numbers are not the same, or we cannot compare with China or the US. But so this is the summary of this slide. It seems that China, I have nothing against China, okay? But I would like to, as a consumer, I would like to choose who is producing under which conditions, because I have a sacrifice in my country. We have in the past or in the near present to stop do mining because of the environmental risks, okay, mainly. Okay, in the case of coal, this is another issue, okay, but I show these statistics just because was the only available, okay. So regarding the environmental conditions, we can shift to rare earths, okay. And if we remember that in a former slide I show you that the biggest producer of rare earths and the biggest consumer of rare earths as a raw material, so the metallurgy is produced mainly 99% fully in China. Okay, these are the statistics. You can see here the full article. Per 1 ton of rare earths, we can or we could have several risks. We have here 60,000 cubic meters of waste gas, 2,000 cubic meters of water polluted, okay, also polluted, and we could have, so gas, liquid, and solid, okay? We could have per 1 ton from 1 to 1.4 tons of radioactive waste, okay? This is the situation of what we have to handle when we produce 1 ton of rare earths, okay? And regarding the impact on the environment, this is usually made in ponds, which not, okay, you can find details here. I didn't want to extend here. You can find details in this link. They say that, or they make this estimation that 1 ton of rare earths can affect 2,000 square meters of vegetation, 300 cubic meters of soil, of topsoil, and it could produce 2,000 cubic meters of tailings, which are containing this and this that we talked about before. Okay, so if we leave these key elements, production, under this risk, okay, that we cannot see, out of sight, out of mind, you think that we can accept this? Okay, we have in Spain deposits, in Greece. Ramona, you also can say something afterwards. You have in Greece deposits of rare earths. In Europe, we have a big deposit in Sweden. We have several spots in which we have rare earths, but we have the same problem that we told before. It is not economic to face this production if we have to compete under different conditions. Okay, so the final reflection is: don't you mind who and how do mine? I am worried about that, and this is why I selected this subject to talk about. Okay, so we cannot forget that responsible production, that is always or usually it's easy to say to the companies, do responsible production, okay, but if responsible production is not followed by a responsible consumption, if we as consumers cannot select what we buy, what we consume from the very beginning of the production chain, okay, starting from the raw materials and the way they produce or we produce these raw materials, how they or we process them, etc. Then if we continue this out of sight, out of mind, we are not going to solve efficiently this problem. Okay, so okay, this was my intention to this talk. Thank you very much for your attention, and of course, if you have some question, I am open to answer. Okay, thank you very much.
Thank you so much. Actually, Professor, I have a question for you. And maybe I will sound like very cruel or naive. However, I think we all have to consider the other aspect. For example, for this extreme situation that you presented, like child labor and things like that, it exists, okay? Until now it exists. However, it is their life. I mean, even if we boycottage or sabotage and do us from the consumer part, do it responsible consumption or purchase of anything, and we have to consider the sustainability and the conditions, labor conditions, etc. However, what those people will be like, where they will be, because the transition phase will be not like 1-2 months, it will be years. So what about them?
Of course, and I can even change the question, thinking in the past. How many generations work under those conditions? Okay. Of course, it is difficult. This is not a matter of changing in one generation. Okay. But this is a fact. And if a consumer, we consider the consumer is at the end of the production chain, because is the target of the production chain. Okay. If we as consumers cannot distinguish, cannot clearly see where things come from, okay, this problem is going to continue. Of course, it is difficult to solve world situation. We know what is the world, and we have many problems, and okay, this is the situation. But what I want to point in this presentation was, when we or what we have to transmit or to see or to say clearly to people that we have the tools to do mine and metallurgy with the best available technologies, with the better conditions for the environment and the better conditions for the people working, creating jobs or whatever, okay? And when we decide that we are not going to do to mine, okay, we are promoting these other activities. So at the end of the day, we are responsible of this at some extent, okay? And we have to make or realize that this is the situation. We probably consume something now. We have now something that that if we follow the thread in the end, it can be produced some microgram halves of the of raw material in Congo by a child in Congo or other part of the world. Okay, so this for us at least should be something that have to or that has to make us think about it. Okay, how we can change this situation. Okay.
Yeah, yeah, you are right. Don't get me wrong. I wasn't mean that, okay, nothing will be changed, so why to change it, or why to do so because some other bilateral losses will be following. I didn't mean this. However, I was more like to the direction that first, I think we have to find out and collaborate with authorities, I don't know, governments, in order to find first the mitigation plan, the plan B for those peoples, and then as individuals to reconsider what we want, how we can get these sustainable sustainable activities.
I agree. You pose an action plan, which is has to have these steps. Okay, it's clear. So because the problem has to be solved outside these countries and within these countries. Okay.
Yeah.
So it's a shared responsibility, and so we have to share also this solution. We have also a share in this solution. Okay.
Yeah.
So thank you very much, Ramona, for your comment.
Is Lina here? I think we have to share the link for the question and link.
Yeah.
if I'm not wrong.
Yes, I'm here.
Yeah.
Are there more questions? Anyone else, would you like to participate?
Okay, I guess we can go to the link. Lina, you can share. Okay, so thank you very much to all of you for participating in the course.
Thank you. Lina,
Thank
can
you,
you remind
Professor
participants?
Maria. Thank you, Professor Oscar Jaime. Thank you, Mateo. And thank you, Professor Smith.
Lina, can you remind participants what they have to do? It's like the link, and then they have to submit their answers within 1 hour, right?
Yes, I will. Give me 1 sec. So regarding the evaluation, we have the questionnaire. So you have 1 hour to solve the questionnaire. There are 20 questions. So please, only one questionnaire per person. So yes. Did you get the link?
Yes, the link now it's in chat.
Okay.
Or maybe Lina share also the screen. Maybe they have like just to see the link because it went like very up in the conversation. I don't know if it is easy to do.
1 sec, I will share the Okay, can you see my screen?